Welcome to The Explainer. Today we're looking at Earth and planetary tech, and we're going to see exactly how we bridge our understanding of the Earth right under our feet with the vast cosmos high above us. And interestingly enough, we're doing it through a very specific lens, the literal academic categorization from Science Direct. I mean, think about it. When you try to organize the sum total of human knowledge, where do you put the stars? Where do you put the soil? And how on earth does human invention connect them? Well, we are going to unpack the deep intersection of Earth and planetary sciences with science and technology.
Okay, let's dive into this. How do technology and planetary science intersect? It's a massive question when you really pause to think about it, because on one hand, you've got the study of billion-year-old rocks, massive tectonic shifts, and distant swirling galaxies, right? But then on the other hand, you have cutting-edge silicone chips, incredibly thin fiber optic cables, and super complex software algorithms. So how do these seemingly completely different worlds collide to create the modern landscape of scientific discovery?
To answer that, we really have to look at how scientific literature actually organizes human knowledge today. Take a look at the structure of this exact URL path from Science Direct. This is literally the foundational roadmap for our entire analysis today. See, it starts with topics, then drills down into Earth and planetary sciences, and nested right inside that, just inextricably linked, is science and technology. Now, this digital filing system, it isn't an accident. It actually tells a really profound story about how we categorize things. It shows us that in the minds of the world's leading researchers, our understanding of the natural universe is completely dependent on and categorized alongside the tools we build to measure it.
So, the crucial point is breaking down the first half of that taxonomy, Earth and planetary sciences. As it's defined here, this is the academic macro category dedicated to the study of our home planet and the celestial bodies that share our universe. Honestly, it's the ultimate where are we and what is all of this made of category. It houses absolutely everything from terrestrial volcanology and deep oceanography all the way to the study of Martian soil samples and the atmospheric composition of exoplanets literally light years away. Fundamentally, it's the science of places.
And this brilliantly illustrates a really fascinating duality. On one side, you have Earth sciences, which inherently has an inward focus, right? It's looking down at our physical world structure, the grinding tectonic plates, the deep ocean thermal currents, the complex atmospheric dynamics that give us our daily weather. But then, directly contrasting that, yet fundamentally linked to it, you have planetary sciences. This is the outward focus, projecting our gaze into the solar system and far beyond. Now, you might be wondering, why does academia group them together? Well, it's because of comparative planetology. The physics and chemistry that govern a volcano in Iceland are the exact same fundamental rules governing a cryovolcano erupting on Saturn's moon Enceladus. To understand what's out there, we absolutely must understand what's down here.
But how do we actually do all that exploring? Well, this brings us to the second half of our source taxonomy, science and technology. And this isn't just some separate bucket of abstract knowledge, it is the practical application of knowledge. It serves as the essential bridge and toolkit for modern scientific discovery. I mean, think about it. You simply cannot study the Mariana Trench or map the surface of Mars with just the naked eye and a spiral notebook. Technology is the vital connective tissue that actually makes the inward and outward focus of Earth and planetary sciences a reality.
Let's move to and see how this builds, practically speaking, and kind of map out the mechanics of it all. First off, technology provides the actual physical tools for exploration. We're talking autonomous Mars rovers, deep-sea submersibles, and massive orbital satellite arrays monitoring our atmospheric changes. Second, it powers data analysis and research platforms. We are literally collecting petabytes of data from space and Earth sensors every single day. It takes massive supercomputers and incredibly advanced algorithms to actually make sense of all that noise. Third, and this circles perfectly back to our starting point, it drives academic databases like Science Direct itself. That's what allows scientists globally to share, cross-reference, and access these massive findings instantly. And finally, it actively merges Earth-based findings with space observation, which lets us seamlessly use Earth as a giant laboratory to decode the rest of the cosmos.
As we wrap up this explainer, I really want to leave you with a provocative question. What does the future actually hold for our understanding of planetary sciences? If a simple academic taxonomy from today shows us just how deeply intertwined our tools are with our cosmic discoveries, imagine what tomorrow brings. What is the next generation of artificial intelligence, quantum computing, or advanced propulsion systems going to unlock for us? Every single new piece of technology is a brand new lens through which we can view our planet and the stars. So definitely keep a close eye on those technological leaps, because they aren't just cool gadgets, they are the literal vehicles of our future discoveries. Thanks so much for joining me to explore this fascinating intersection today, and as always, keep